Okay, it's time to take a look at quadratic inequalities. So what this is it's just a quadratic, but instead of being a function or equal to something, we have a less than sign, making it an inequality. So what we want to do is find out which values of x make the expression less than 0. So here's how we're going to do that. We first have to find what values of x make the expression equal to 0. So we're essentially saying in the function y equals x squared minus 6x plus 8, y is equal to 0. So what does that mean we are finding here? It means we're finding the x values where y is 0, which are the roots of the quadratic. So in order to find the roots, we just factor. And we see that the x values are 4 and 2. So these are the roots of the quadratic y equals x squared minus 6x plus 8. So let's just draw a rough sketch of that graph. Our roots are 2 and 4, and the parabola is going to look something like this. Not a very accurate graph, but we don't really need to be accurate for this because we only care about x values. So in the inequality, we're finding where is the value of the expression less than 0. And this graph represents that value. So where does the graph dip below a y value of 0? Well, that means where is the graph below the x-axis? And that would be in this range right here. So the x values where the graph dips below the x-axis are between 2 and 4. So that is our answer. X is between 2 and 4. So that is how we solve these quadratic inequalities. We can draw a rough sketch of the graph to see what values of x produce the correct value for y. So again, we just factor it, set it equal to 0. So we're finding where is y equal to 0. What are the roots of the graph? Then when we get the roots, we just draw a rough sketch of the graph. So now we want to see where is the value of this expression greater than 0. Well, that means where is the y value of the graph greater than 0, above the x-axis? That would be going in this direction, up and to the right, and in this direction, up and to the left. So the range of x values we just drew in what is basically a little number line here. We can see that x is less than -4, or x is greater than -1. So these values for x will make this expression, this inequality, true. So now we have greater than or equal to. So that's going to change things up a little bit. But to start off, we just do the same thing. We factor the expression, set it equal to 0, and find the roots of the graph. Now we'll plot them on this x-axis. see what the graph is going to look like, something like that. So where does this expression greater than 0? Well, that would be where the graph is above the x-axis, so going in this direction and going in this direction. But what's different about this one is because it's greater than or equal to, the value of this expression could also be equal to 0. So where is it equal to 0? Well, that would be where y equals 0, right on the x-axis, where these roots are. So when we write the final inequality, we have x is less than or equal to -3, or x is less than or equal to 5, because we're including the roots since it is equal to 0. So for this one, it's just the same thing, but now because we have a coefficient that's not 1 in front of x squared, we have to factor it differently using this method. Draw the x, write the factors of 2, write the factors of 3. We see that that's not going to produce 7, so we just try again. There we go. 6 plus 1 is 7. So we will get x plus 3 times 2x plus 1, setting it equal to 0 to find the roots. The roots are -3 and -1/2. Plotting these on the graph, we'll get something that looks like that. The parabola. There's the parabola. So where is this expression less than 0? That is where the graph dips below y of 0, dips below the x-axis, so right in here. And because it is just less than, not or equal to, it does not include the roots, so the inequality that we write will not have the less than or equal to, just less than, as we started with. So you might have noticed a pattern by now that it seems like when it's greater than, we're looking at outside of the parabola. When it's less than, we're looking inside of it for the solution. But the reason it's important to still draw the graph is because this is not going to fit that pattern. And you will see why in just a second. So when we're factoring with a negative leading coefficient, it's best to factor that out first. Now you might remember when you divide by a negative number in an inequality, you change the direction of the inequality. But we're not going to do that here because we haven't divided by the negative, we just factored it out. So we haven't actually changed the expression at all. But now we just factor what's inside the parentheses here, being multiplied by the negative. So we're going to draw our big X here. This is actually a fairly challenging factoring problem. So let's see if we can figure this out. Since 13 is not that high of a number, I'm going to guess that we have the lowest result we can get on this side, which would be the numbers closest together. 3 and 4 are factors of 12. And then 2 and 2 for that side. That is not going to work. Oh, one of them has to be negative. Let's see. There we go. That's going to work. 3x plus 4, 4x minus 1. Setting it equal to 0 for the roots. If you're not quite this fast with factoring it, don't worry. I've just had a lot of practice, but when I started out, it did take a while to do hard problems like this. But just keep practicing and you'll get faster. Anyway, so the roots here, this negative out here doesn't really mean much for finding the roots anyway. The roots are negative 4/3 and 1/4. Now here is where this negative means something. So this is about where our roots would be. But we have to remember is the only other part we care about of this graph besides the roots is the sign of the leading coefficient, because that determines what the parabola looks like. Because if it's negative, the parabola flips upside down and we have a graph that looks like that. It's an upside down parabola. That's very important to remember. Besides this number determining the steepness of the graph, it also determines, which we really don't care about here for the drawing, but we do care about whether it's going up or going down. So the negative means it's going down, and that's going to change our answer, because now we're looking at less than or equal to. Where is the graph less than 0? Where's the y value less than 0? Well, now that's going to be outside. The graph is going down in this direction, so it's outside the parabola on both ends, where the graph is below the x-axis. And also don't forget it's or equal to, so we include the roots as well. So the answer is going to be less than or equal to negative 4/3 or greater than or equal to 1/4. So with this one, it's the same thing. It's a negative, so we're going to factor that out. So how can we take factors of 4 and add them to get 6 or negative 6? Well, we can't do that. So this expression is actually unfactorable, which means we have to solve it using completing the square. So this is going to be x squared minus 6x plus 9. So we'll take out the 9, add in the minus 4, and set it equal to 0 to find the roots. So now bringing the negative 13 out of this parentheses, multiplying by the negative here, we'll get plus 13. So here's what we're going to do now. We'll bring the 13 over to the other side. We'll get negative 13, but then we'll have this negative here. So we can divide both sides by, divide or multiply by negative 1. The negatives disappear. And so we'll get x minus 3 squared equals positive 13, since we remove the negatives from both sides. Take the square root of 13, and then we'll take this minus 3, move to the other side. So again, I'm skipping a few steps here, but this is just still the standard completing the square method. So these are our two roots, square root of 13 plus 3 and negative square root of 13 plus 3. So now you could take the time to approximate about where those are in your head, but in case you haven't noticed by now, it really doesn't matter in relation to to the y-axis. So we can just draw the graph. We can draw it as just the x-axis. This is the x-axis here. And it doesn't really matter how far apart the roots are or anything, because we just have to know what they are. The only reason we're doing this is to visualize it with the graph, but you should recognize that negative square root of 13 plus 3 is less than positive square root of 13. But other than that, just remember that with a negative leading coefficient, the graph is upside down, so it looks something like that. And we want where is y greater than 0. That's going to be in this area right here where the graph is above the x-axis. So the inequality is going to be the first root is less than x, and x is less than the second root. So just be careful to write that out since it's kind of long. So here's another problem where we have a coefficient not 1 there, so we draw the x to factor it. But now we see that no matter how we arrange the factors of 7, which are just 1 and 7, we can't get to 3. So this is another non-factorable expression, which means we're going to solve by completing the square. You could also do, in fact, you know what? We did completing the square already, so let's do quadratic formula. You can use either one of those. So quadratic formula, if we set this equal to 0, then x is, hopefully you still remember this, negative b plus or minus the square root of b squared minus 4ac over 2 times a. So let's see if we can do this in just a couple of steps. So we're going to get negative 3 plus or minus the square root of, what is this? This is 9 minus 8 times 7 is 56. 9 minus 56 is negative 45. Sorry, negative 47. So we can actually stop right here because we see that we're taking the square root of a negative number, which is going to give us imaginary numbers. Plus or minus an imaginary number. That means that both of our roots are imaginary. So there are no roots to this graph. Just to confirm that, we could use the discriminant, b squared minus 4ac. This is, again, 9 minus, again, it's what we just did in here, the part under the square root. We get negative 47. So we could have done this first to see if there were going to be roots. We could have done that for this one here, which also happened to be non-factorable. Whenever it's non-factorable, if you want to make sure you're not going to waste time trying to find real roots when there are none, you can just use the discriminant. Here we got lucky, there were real roots. But here there are none. So if this is our x-axis, we have a positive leading coefficient, so the parabola is pointing upward, but it does not touch the x-axis. It just looks like that. So how do we find the x values and solve this inequality? Well, we're actually going to stop here and look at inequalities like this, along with other quadratic inequalities with irregular or unusual roots, like this problem. We're going to look at that in the next video.